Hey guys, welcome to lesson 821, day 1. Today we are going to learn, well, I'm making this video like after the fact. So today we learned about something called complex numbers, also known as imaginary numbers. So we will talk about like where this came from and why it exists, but let's start by kind of showing it in action. So if I asked you guys to solve this equation right here, x squared plus 1 is equal to 0. We would go ahead and follow our usual equation solving steps, meaning, get x by itself. So let's start by subtracting 1 from both sides. So we have x squared is equal to -1. And then, logically, because you want x alone, you would say, okay, well, let's go ahead and square root both sides. And that would give me an answer of the square root of -1. And technically, when we square root something, we end up with a positive and a negative answer, so I'll throw that in there. And we can't really go anywhere from there because when you try to take the square root of -1, and I'll just go ahead and demonstrate that in our calculator, when you square root -1, you end up with an error, right? It says non-real answer. So, in fact, let's try to square root just any old random number. How about -5? Sure enough, we get another error message, right? So the whole idea here is we actually can't take the square root of a negative number. And if you think about it, that's pretty logical, right? If I asked you to think of a number where when you square it, you end up with a negative answer, you wouldn't be able to come up with anything, right? Because it's absolutely impossible to square a number and end up negative. Because a positive number squared is positive, a negative number squared is positive. There is no such thing as squaring to get a negative number. So it wouldn't make sense to square root a negative number and work backwards when we had no way to get here in the first place, okay? So that's why it's an error, and because of that, we had to kind of work around it. So this being said, this guy, Raphael Bombelli, invented what's called the imaginary number, which is, complex numbers, and he dubbed square root of -1 as I. So square root of -1 we will now refer to as I, and that being said, we can simplify these square roots when they have negative numbers in them. So here it says that -4 is equal to 2i. So the reason that that is true is because you can rewrite this. Okay, I can rewrite the square root of -4 as the square root of the square root of 4 times -1. Okay, all I did was I rewrote the -4 inside of that square root. So the rules of radicals or roots is that I can rewrite these. If there's multiplication inside, I can actually split them up. Okay, so I can rewrite this as square root of 4 times the square root of -1. Now at this point, I can actually simplify this. I know the square root of 4 is 2, and we just discovered that the square root of -1 is called I. So we're going to take the square root of -1 and just replace it with an I. And that is why the square root of -4 just simplifies to 2i. Now, you might notice that, square root of -4 is 2i, square root of -9 is 3i. In fact, what basically is happening, long story short, is we can square root the positive number, get that number, and then we just chuck an I in there, okay? You don't always have to do like all this work. So square root of 9 would have been 3, and then you put an I in there for the -1. All right, so if you're then in a circumstance where you can't actually take the square root, like 2 is a number that you can't actually take the square root of, that's okay. We could just leave it in the square root, and we still put an I there on the outside, just like we did before. All right, so let's talk about some more things we can do with I then. We can raise I to powers just like we can raise numbers and variables to powers, and some interesting things happen when we do that. So I squared, if you think about it, would be the square root of -1 times the square root of -1, right? AKA the square root of -1 squared. Now, anytime you square a square root, that just cancels the square root and square action, and you just end up with what's inside. So that tells us that when I square I end up with -1. Now, this is like a huge thing. We're going to use this I squared equals -1 a ton. So like here, I cubed, well, if you think about it, I cubed can be rewritten as I squared times I, right? I just rewrote I cubed. Now that I'm still accounting for all three, I can replace the I squared with -1 because I just discovered that I squared is -1. And then here, I end up with -1 times I. I can't really do anything about that I, but -1 times I really just equals -1I, or negative I. And that would be my answer there. I to the fourth. Now, again, we want to think about how we can rewrite this to make our lives easier. We can think of I to the fourth as I squared times I squared. Okay, all four have been accounted for, and that means we can say that's the same thing as -1 times -1, because again, I squared is -1. So you calculate this, you get an answer of 1. All right, moving on to I to the fifth. Now, as you get bigger and bigger in number, you can get kind of creative. It's probably the easiest, if you're not feeling confident, to just rewrite in terms of I squared every time. So like here, I can say, well, I squared, if I raise that to the second power, I'm just raising it to the second power instead of writing them both out like this, because according to exponent rules, this is the same as I to the fourth. So now I've accounted for 4 of them, but I have 5, so let's put another I out here. So there's 2 times 2, I have 4, plus 1 is 5. So now let's go ahead and replace what I know I can. So I squared is -1, so -1 squared times I. And then this -1 squared is just 1. I sticks around, so my answer is just 1I, or I can also just call that I. All right, I do want to point out an alternative method that you could have done for this, just to show you that you can get creative with it. So a second ago, we talked about I to the fourth, right? I could have rewritten I to the fifth as I to the fourth times I instead of what I did here. And this could have worked just as well, right? Because if I remember that I to the fourth equals 1, I can say, okay, well, 1 times I equals I. And I would have gotten the same exact answer. So just to point that out. Okay, let's try one more. I to the sixth. So again, if I wanted to rewrite that in terms of I squared, I would say, okay, well, I squared to the third power, 3 times 2 equals 6. I've accounted for all of them. So that's the same thing as -1 to the third power. -1 to the third power is -1. And so that's my answer. Something I just want to point out is anytime if you're going to put these things in your calculator, just be very careful and make sure that anytime you raise a negative number to an exponent, you put it in parentheses, or else it will not come out right a lot of the times. Just anytime you're raising anything to an exponent. All right. Okay, moving on. Let's do some simplifying. So here, if I have the square root of -25, I have a 25 in there, which I know I can rewrite this. Remember what we kind of did in the last examples. If I have 25, I can rewrite this like that. And, that's the same thing as root 25 times root -1. Now the 25 can be square rooted and it turns into 5. Square root of -1 is just I, so this is 5I. This one, 2I times 3I, well, 2 times 3 is 6, I times I is I squared. So we end up with 6 times -1, because again, don't forget, I squared is -1, so we get -6. All right, one more here. 2 times -5 gets you -10, and then I squared, we have an I squared here and an I, so there's a total of 3 of those. Oops. So we got an I cubed. All right, so -10 times I cubed. We could go back to that last page and look at what I cubed was, right? I cubed is actually the same as -I. Okay, so what we can say is that this ends up equaling -10 times -I. Negative times the negative equals a positive, so our answer would just be 10I. All right, so that is it for these examples. I do want to talk about one open math example, just so that we're feeling comfortable with it. This is that big fun problem in open math. It's number 3. So let's say I have like huge numbers here, right? Like I to the 67th. It's not as daunting as you might think. You just have to think about rewriting it in terms of I squared. So if I look at 67 and I'm like, let's start with I squared. What can I raise I squared to get as close as possible to 67? Now you have to realize that 67 is an odd number, so we won't reach 67 directly, but we can reach 66. 66 is the next closest even number that we can reach. So 2 times what equals 66? Well, that would be 33. 2 times 33 is 66. But I still have 67 i's, so let's put another one out here. All right, so this I can simplify to -1 to the 33. I squared is -1. And then times another I. So -1 to the 33rd power is going to equal -1. Okay, so this becomes -1i. So our answer is just -i. You can write -1i as well. I don't care. All right, so let's do another one. I to the 13th. So let's do the same thing. So I to the 2nd power. 2 times what gets me as close as possible to 13? Well, 12 is the next closest number, so let's figure out 2 times what would get us to 12. Hopefully you would realize that that's 6. But that's only 12 i's. I need to account for the last one, so let's put that one out here. That'll just be chilling there. And then let's simplify. So -1 to the 6th, and then times I. So -1 to the 6th ends up being +1, so 1 times I just equals I. A trick that you can use is if you are raising -1 to an even power, it'll always become a +1, and if you're raising -1 to an odd power, it'll always become a negative. All right, let's try this one, I to the 90. Now, it's a little easier when your exponent is even number, because then we can reach it pretty easily. 2 times what equals 90? Well, 45. So now I don't even need to have any extra i's on the outside. I just have to do -1 to the 45th power. Now because it's an odd number, this is going to end up being -1. Okay, and then last example, 72, another even number. So I squared, just always start with I squared. 2 times what equals 72? Well, that would be 36. So -1 to the 36th power. This is an even power, so I'll end up with a +1. All right, and that is it. Hopefully your open math problems go okay. Oh my goodness. I'm trying to end this recording and I can't even like find. It's not opening back up. All right, there we go. All right, give them a try.